Theorem. Let a random sample of size n is drawn from an infinite population or with re- replacement from a finite population. The standard deviation of the sampling distribution of x mean is equal to the population standard deviation divided by the positive square root of the sample size, that is sigma x standard is equal to sample standard deviation upon the standard sample number of sample square root of number the sample size square root of sample size, that is sigma standard deviation of sample is equal to population is this ठीक है, sample is this sample size, sampling x mu is equal to population standard deviation upon the square root of a sample size. Proof. Let x1 and x2 so on to xn be a random sample selected from the population with standard sigma. X mean is equal to summation and I is equal to integer from 1 to n and x pass all integers upon n. Taking variance on both sides, variance x bar is equal to variance of summation and I integers I from n and x pass to all integers upon n. Squaring sigma square upon x. Sigma we will use for denoted to the standard deviation, or yeah, here the variance. Variance is equal to 1 upon n square, both side variance summation I is equal to x upon iota. X integers, all integers. Variance is equal to 1 upon n square. We can write the sigma for variance for all x values, x1 plus x2 plus so on to xn. So variance is equal to 1 upon n square. We will product with variance of x1 plus variance of x2 plus so on to xn. I value here we use variance of x is equal to 1 upon x square. We use this term variance of x upon n is equal to s square. So we will here can write s plus variance plus variance, can write only as variance plus variance. Variance is equal to 1 upon n square is n times of n variance, sum of all variance, and the variance is equal to 1 upon n variance square root on both sides. Then the standard deviation is equal to standard deviation of population upon the sample size, square root of sample size. Hence proof.